So in the last lecture, we've seen that what is the Squart's inequality. Okay, the mod of inner product of alpha beta is less than or equal to norm of alpha into norm of beta for all alpha and beta belongs to V. Okay, so this is the Squart's inequality, and also we've seen that the triangle inequality. Okay, what is the triangular inequality? Norm of alpha plus beta is less than or equal to norm alpha plus norm beta. Okay, in an inner product space, norm of alpha plus beta is less equal than norm of alpha plus norm of beta. Again, this one is the proof. So today we will see the new concept. What is the orthogonal vectors? Okay, so look at the definition. What is the orthogonal vectors? Okay, anyone knows what is the orthogonal vectors? Hmm? What is the definition of orthogonal vector?
If the dot product of that two vectors is equal to 1, then they are orthogonal.
Dot product of two
Or
vectors,
otherwise, they are perpendicular.
0, not 1. Okay, dot product of any two vectors. Okay, in Euclidean space, if dot product is 0. Okay, but in an inner product space, if the inner product of two vectors is equal to 0. ओके, तिथे कोणता डॉट प्रोडक्ट कसा डिफाइन केला होता आपण? A डॉट बी इज इक्वल टू ए बी कॉस थीटा ना. Okay, तो पर्टिक्युलर एक
Yes.
ऑपरेशन साठी. So here in the inner product space, if suppose there are two vectors and inner product of that two vectors is 0, that means they the two vectors are orthogonal to each other in Euclidean space if they are perpendicular. Okay, so look at here. Let's suppose alpha and beta are the two vectors. Alpha and beta be the vector in an inner product space. Vectors in an inner product space, IPS. Okay, V. Then alpha is said to be orthogonal to beta. Alpha is said to be orthogonal to beta if the inner product of that two vectors is equal to 0. Okay, now look at this, some properties of orthogonal vectors. Number one, not number one, the relation of orthogonality in an IPS, that is inner product space, is symmetric. Okay, what is the meaning of symmetric? If alpha is orthogonal to beta, okay, what is the symmetric relation? If x is related to y, then y is related to x. Okay, so here the relation of orthogonality in an inner product space, it's symmetric. That means if alpha is perpendicular to beta, then beta is perpendicular to alpha. That is, the inner product of alpha beta is equal to 0. Then inner product of beta alpha is must be 0. Okay, the relation of orthogonality in an inner product space is symmetric relation. Symmetric. It is symmetric relation. That means if alpha is orthogonal to beta, okay, orthogonal to beta, so it implies what? By the definition, inner product of alpha and beta is equal to what? 0. Okay, implies and implied. Okay, so this implies and implied. What is alpha beta? Inner product of alpha beta is equal to inner product of beta alpha bar, which is equal to 0. Okay, so this implies and implied inner product of beta alpha double bar. Okay, double conjugate. This is equal to 0 bar. But what is 0 bar? 0. Okay, so this is beta alpha, which is equal to x plus iy चा conjugate काय येणार? दोनदा conjugate घेतल्यानंतर x minus iy conjugate and again is equal to x
X
plus
plus y. IY.
iy. Okay, so this is beta alpha, inner product of beta alpha, which is equal to 0. So this implies an implied beta is orthogonal to alpha. Any doubt?
No, sir.
Okay, so we can say we can say that two vectors, okay, alpha and beta in inner product space are orthogonal if the inner product of that two vector must be equal to 0. Okay, now the second note, second property. If suppose alpha is orthogonal to beta, then every scalar multiple of alpha is again orthogonal to beta. Okay, look at it. If alpha is orthogonal to beta, then every scalar multiple of alpha, scalar multiple of alpha is orthogonal to beta. Okay, for example तुम्ही R2 मध्ये तुम्ही हे अज्युम करू शकता. For example, okay, if suppose these two vectors are orthogonal to each other. Okay, suppose these are the two vectors are orthogonal to each other. Okay, suppose this is alpha and this one is beta. What is the scalar multiple of alpha? If k is positive असेल तर तो इकडे जाईल. Okay, तेव्हा हा कुठे येईल? Suppose this is alpha. हा k alpha कुठे येईल तुमचा? इथे कुठे येईल. Okay, is it correct? This is k alpha and this one is beta. Then again k alpha is positive. Okay, and negative असेल तर तो इकडे कुठेतरी जाईल. Okay, इकडे येईल पॉझिटिव्ह असेल तर, आणि निगेटिव्ह असेल तर तो इकडे सर्कल पुढे. इज इट करेक्ट? Okay, so if alpha is orthogonal to beta, then every scalar multiple of alpha is orthogonal to beta. Okay, suppose here the alpha is orthogonal to beta. Okay, so what it implies, the inner product of that two vectors must be equal to 0. So let take any scalar, let k be any scalar. So consider the product of k alpha with beta is equal to k into inner product of alpha beta. Okay, by using linearity property. Okay, linearity property. So this is k into, what is the value of this one? 0. So equal to 0. So scalar multiple of alpha is what? Alpha is orthogonal to beta. Any doubt?
No, sir.
And the third note is the 0 vector is the only vector which is orthogonal to itself. Okay, what is the meaning of this one? Look at it. The 0 vector, the 0 vector is the only vector which is orthogonal to itself. Okay. Let's suppose alpha with any arbitrary vector belongs to V. Okay. काय म्हणते हा? Suppose here the V is alpha is suppose alpha is orthogonal to alpha. That is itself. Alpha is orthogonal to itself. So what it implies? If suppose alpha is orthogonal to itself. Okay, what is the meaning of this one? Null product of alpha with alpha is equal to 0. When this possible? if and
alpha
only
equal
if
to 0.
alpha is equal to 0. That means 0 is the only vector which is orthogonal to itself. Is it correct?
Yes, sir.
Okay. So these are the three nodes are there. Okay. What is the definition of orthogonality? If alpha and beta are the two vectors in an V, that is inner product space V, then alpha is said to be orthogonal to beta if inner product of that two vector is 0. ओके. हाच प्रोडक्ट आपण R2 मध्ये कसं डिफाइन करतोय? इफ A and B are the two vectors, then A dot B is equal to AB cos theta. ओके. जर ते परपेंडिक्युलर असतील तर थीटा किती होईल? 90 cos 90
0.
0. That is AB dot B is equal to 0. Then they are perpendicular. Okay, in R2 space मध्ये पर्टिक्युलर तो एक डिफाइन केला आहे तसा तो. ओके, म्हणजेच इन R2 मध्ये मी कसं डिफाइन करणार हा? In R2 space, inner product of alpha and beta is equal to alpha dot beta dot product, which is equal to alpha beta cos theta, where theta is the angle between alpha and beta. Okay. So particular एका space साठी आपण define केले dot product. Okay, but here we don't know what is V, actual V. Okay, so space of matrices चा असेल किंवा function चा असेल. Okay, any doubt?
No, sir.
Now the next definition is orthogonal to each vector in S. Okay, when we say that this alpha, suppose S is the non-empty set of V. S is the non-empty subset of V, then alpha is orthogonal to this set V if this alpha is orthogonal to each and every vector of S. Okay, look at this one. Definition. Okay, what is the definition? Let V be an inner product space. Let capital V be an inner product space and capital S is non-empty subset. Okay, non-empty म्हटलं आहे non-empty subset of V, capital V, and a vector alpha belongs to capital V is said to be orthogonal to the set S, to the set capital S if it is orthogonal to each vector in capital S. Okay, suppose this is V. Okay, and this one is S, which is non-empty, and alpha is the any vector belongs to S. Okay, and suppose these are alpha 1, alpha 2 up to so on. This is alpha 3. Three vectors and are in S. Okay, when we say that this alpha is orthogonal to this set S, if inner product of alpha and alpha 1, alpha with alpha 2, alpha with alpha 3, किती यायला हवा हा? 0. Okay, then we say that this alpha is orthogonal to the set S. Okay, any doubt?
No, sir.
Okay, take सगळं मेकॅनिकल पार्ट आहे, तुम्ही वाचल्यानंतर ही समजून जाईल तुम्हाला, इतकं सोपं आहे. Okay, now what is the orthogonal set? Now next definition. Orthogonal set. What is orthogonal set? Let S is what? Be the set of vectors in IPS V. Be the set of vectors in an inner product space, capital V. Then yes, set yes is said to be an orthogonal set, and orthogonal set if any two distinct vectors in yes. ओके डिस्टिंक्ट का घेतलंय कळेल तुम्हाला. तर एकच वेक्टर घेतला आणि इनर प्रोडक्ट त्यांचा जर झिरो झाला. ओके if inner product of alpha into alpha and alpha is equal to 0, then alpha must be equal to 0, no? That's why he has
Yes, sir.
taken these are the two distinct vectors. Any two distinct vectors in yes, capital S, are orthogonal. Okay, suppose the yes contain how many vectors? Alpha 1, alpha 2, up to so on. Alpha n be the set of vectors belongs to yes, okay, which is subset of V, suppose. And inner product of alpha I with alpha j is equal to 0 for I is not equal to j. Okay, जर I is equal to j असेल तर काय होईल itself alpha I हा 0 होईल. Okay, any doubt now? Then the set S is orthogonal set. त्या पूर्ण सेटला काय म्हणायचं orthogonal set. Any doubt up to here?
No, sir.
Okay, now the next definition is unit vector. Tell me what is the definition of unit vector? Hmm. What is unit vector? गप्प बसली की गप्प बसायची हा लागतं तुम्हाला सॉरी हा कुलकर्णी ऐश्वर्या व्हॉट इज युनिट वेक्टर काळे मेगा हॅज लेफ्ट द मीटिंग ओके ढगे अमरचा व्हॉट इज युनिट वेक्टर काजल गवळी व्हॉट इज युनिट वेक्टर हा अमरचा बोला ढगे अमरचा व्हॉट इज युनिट वेक्टर
Vector of length is 1.
वेक्टर विथ लेंथ इज 1 ओके मग सांगा ना माहित
1.
असेल तर ओके सो व्हॉट इज युनिट वेक्टर लेट capital V be an inner product space. Okay, and if the alpha is the vector from V such that okay लेंथलाच काय म्हणतोय आपण इथे norm of alpha is equal to 1 then alpha is called unit vector. Is it correct?
Yes, sir.
Unit vector. Now tell me whether the zero vector is a unit vector. नावातच आहे ना नाही norm of zero is not 1. That's why zero is not a unit vector. Okay, any doubt? If the any vector of length 1 that is norm 1 that is inner product of alpha with alpha square root of inner product of alpha is okay what is norm square root of positive square root of inner product of alpha alpha is equal to 1. Okay, then that vector is called as unit vector. Any doubt up to here?
No, sir.
Now the next definition is orthonormal set. Orthonormal set. Okay, orthogonal झाला आता orthonormal set. Orthonormal set. Let yes be the set of vectors in an inner product space V. Let capital S be a set of vectors. Set of vectors in an inner product space. Okay. एक सेट दिलाय तुम्हाला V मधला inner product space V. Then yes is said to be orthonormal. This set yes is said to be orthonormal set. Orthonormal set if look at here first condition alpha belongs to S implies norm of alpha is equal to 1. That is, inner product of alpha with alpha is equal to 1. Okay, norm of alpha is equal to 1 means positive square root of alpha alpha, inner product of alpha is equal to 1. Okay, now taking square on both sides, we get this one. Okay, this is the first condition. And what is the second condition? If alpha and beta, if these are the two vectors in S, so this implies and alpha is not equal to beta. Okay, distinct vectors. So this implies inner product of alpha with beta is equal to 0. What is the orthonormal set? Inner product of alpha with alpha is equal to 1 and inner product of alpha with other vector other than alpha is equal to 0. Okay. Hmm. This statement tells us that each vector is orthogonal to other vector. Okay, alpha is orthogonal to beta. And here, this first condition tells us that the length of each vector is unit vector. Is it correct?
Yes, sir.
म्हणजेच ऑर्थोगोनल सेट मध्येच आपण एक अजून एक ऍडिशन कंडिशन ऍड कंडिशन कंडिशन ऍड केली. कोणती कंडिशन? इफ each vector length of each vector is 1 and the set is orthogonal, then that set is orthonormal set. An orthogonal set with each length of each vector is unit, that is 1, then that set becomes orthonormal set. So that means orthonormal set is always orthogonal set, but orthogonal set is need not be orthonormal. Is it correct?
Yes, sir.
ऑर्थोनॉर्मल असेल तर तो ऑर्थोगोनल असतोच, पण ऑर्थोगोनल असेल तर ऑर्थोनॉर्मल असेल हे काय सांगू शकत नाही आपण. Okay, now tell me whether 0 is the vector belongs to either the 0 vector belongs to orthonormal set.
No, sir.
एखादा सेट ऑर्थोनॉर्मल सेट दिलेला असेल तर त्याच्यामध्ये 0 वेक्टर येईल का मग? नो. ओके, 0 वेक्टर येणार नाही का? इज इट करेक्ट?
Yes, sir.
Okay. So what is the orthonormal set? Let S be the set of vectors in an IPSV, then S is said to be the orthonormal set if inner product of alpha with alpha is equal to 1 and inner product of alpha beta is equal to 0 if alpha is not equal to beta. Okay, thus the orthonormal set is an orthogonal set. With additional property that each vector in it is of unit length. Okay, is it correct? Of length 1. Okay, and what is the note? An orthonormal set cannot contain 0 vector because norm of 0 is equal to 0, which is not equal to 1. Okay, any doubt?
No, sir.
Okay. एखाद्या वेक्टर स्पेसचा बेसिस दिलेला असेल तुम्हाला समजा. ओके, इफ द बीटा इज द बेसिस फॉर द वेक्टर स्पेस V, whether this beta contains 0 वेक्टर. एखाद्या बेसिस मध्ये 0 वेक्टर असतो का कधी?
No, sir.
नो. जर 0 असेल तर काय होईल? लिनियरली इंडिपेंडेंट होईल का तो?
No, sir. Linearly dependent.
ओके, आता हे का सांगेन मी पुढे कळलं. ओके, एखादा ऑर्थोनॉर्मल सेट असेल तर तो बेसिस फॉर्म करतो वेक्टर स्पेसचा. ओके, एखादा ऑर्थोनॉर्मल सेट तुम्हाला दिलेला असेल तर तो बेसिस कसा होतो वेक्टर स्पेसचा, इनर प्रोडक्ट स्पेस. ओके, कळेल पुढे जाऊन. ओके, आता पण तेवढंच लक्षात ठेवा की ऑर्थोनॉर्मल सेट कॅन नॉट कंटेन झिरो वेक्टर बिकॉज लेंथ ऑफ झिरो इज norm of 0 is not equal to 1 here. Okay, now the next theorem. Any doubt up to here? काही डाउट्स असतील तर विचारू शकता. Okay, now next theorem. Let S contain the m vectors alpha 1, alpha 2 up to so on alpha m. Okay, be an orthogonal set, not orthonormal. Okay, orthogonal set of non-zero vector. म्हणजे हा ऑर्थोगोनल सेट आहे which does not contain zero vector in an inner product space V, capital V, if a vector beta belongs to V, okay, is in linear span of S, linear span of S, then beta k is equal to summation I running from 1 to m inner product of beta with alpha k into alpha k divided by norm of alpha k square, norm square of alpha k. Okay, not beta k, not beta k, beta, sorry. We have k running from sorry, k running from 1 to n, this beta. If beta is the any vector belongs to V, is in linear span of S, then what is the nature of beta? This one, summation k running from 1 to m, k is equal to 1 to m. This is the inner product of beta with alpha k. Okay, म्हणजेच काय येईल, that is beta is equal to beta alpha 1 into alpha 1 divided by alpha norm square of alpha 1 plus up to so on beta inner product of beta alpha m into alpha m, okay, divided by, okay, हा divided by हा तुमचा एक स्केलर आहे. ओके, wait, divided by alpha m square, norm square of alpha m. Okay, this is the scalar quantity. This one is the scalar quantity. So scalar into vector. Okay, हा तुमचा काय स्केलर आहे. Is it correct? Inner product is
Yes,
the
sir.
function from v cross v to f. That means the output of inner product is scalar. Scalar असतो तो. हा तुमचा स्केलर आहे. नॉर्म हा सुद्धा स्केलर आहे. Okay. So this is, so beta is in the form, in this form. Okay, now proof. Let S is the set alpha 1, alpha 2 up to so on alpha m be an orthogonal set. It is given to us, orthogonal set of non-zero vectors. Non-zero vectors in an IPS V, inner product space V. Then for each k is equal to 1, 2 up to so on m, what we have, the set is orthogonal set. That means inner product of alpha j and alpha k is equal to what? 0, where j is not equal to k, and also j running from 1, 2 up to so on m. Is it correct?
Yes, sir.
There are two distinct vectors. The inner product of two distinct vectors is equal to 0. Why? Because the set is orthogonal. That means each vector in that set is orthogonal to the other vector. Okay, give it as an equation number 1 or statement number 1. Okay, what is the linear span? Let linear span of yes. कसा डिफाइन करतो आपण linear span? Gamma belongs to be such that this gamma is in the form of d1 alpha 1 plus d2 alpha 2 plus up to so on dm alpha m. Okay, where the di's are constant. Okay, any doubt up here?
No,
लिनियर
sir.
स्पॅन म्हणजे एखादा वेक्टर तुमचा जर लिनियर स्पॅन मध्ये असेल, इफ सपोज अल्फा बिलॉंग्स टू एल ऑफ एस असेल, सो धिस अल्फा वी कॅन राईट इन द फॉर्म ऑफ समेशन ऑफ linear combination of this one alpha 2 up to so on alpha m. Okay, so this is the nature of this linear span. Okay, where these di's are constant. Okay, be the linear span of s. Linear span of yes. Okay, any doubt up to here?
No, sir.
Okay, now take any vector beta belongs to V. Let this beta be the any vector belongs to V such that this beta is belongs to linear span of S. Okay, what we have to prove here? Beta belongs to V is in linear span of S. Of S. Okay, एखादा वेक्टर तुमच्या linear span of S मध्ये असेल तर तुमचा नेचर हा असा असेल त्या बीटाचा. Okay, so here the beta belongs to linear span of S. Then this beta then this beta we can write in the form of linear combination of C1 alpha 1 plus C2 alpha 2 plus up to so on Cm alpha m by definition of L of S. Okay, any doubt?
No, sir.
So that is beta is equal to summation j running from 1 to m Cj alpha j. Give it as an equation number 2 in the summation form. Okay, now we have to prove that what we have to prove, so beta is equal to summation k running from 1 to m. Okay, inner product of beta with alpha k divided by norm square of alpha k into alpha k. Okay, पहा या स्टेटमेंट कडे आणि या स्टेटमेंट कडे नीट पहा. If I prove the Cj value of Cj of this one, then result holds. Is it correct?
Yes, sir.
Okay, जर हा मी कॉन्स्टंट तुम्हाला हा दाखवला तर रिझल्ट होल्ड होईल ना. पुटिंग द व्हॅल्यू ऑफ Cj in equation 2 we get the required result. Okay, now look at here. Now we have to prove that this one. Okay, for let's for each k is equal to 1 2 up to so on m. Okay, consider inner product of this beta with alpha k is equal to what? Inner product of what is the value of beta here? This one from equation 2. Okay, summation j running from 1 to m Cj alpha j. Okay, so write down here summation j running from 1 to m Cj into alpha j with alpha k. Okay, from 2. Okay, by the linearity property of inner product space, this one we can take outside this summation into constant k running from 1 to m Cj alpha j with alpha k. Okay, by linearity property of inner product. Any doubt?
No, sir.
ओके, ह्याला जे रनिंग फ्रॉम 1 to m करा रन. ओके, m टर्म्स असतील त्यातनं मी सीजे कॉमन काढलाय, पुन्हा तो समेशन मध्ये लिहिलाय, तर काय येईल? ओके, बीटा विथ अल्फा के. ओके, Now this is equal to summation inner product of beta with alpha k is equal to, okay, now run this J, C1 alpha 1 alpha k plus C2 alpha 2 alpha k plus up to so on ck alpha k alpha k plus up to so on cm alpha m alpha k. ओके, कुठेतरी हा k कोइन्साइड होईल तुम्हाला j ला. ओके, is it correct?
Yes, sir.
Okay, now the inner product of beta with alpha k is equal to, this is C1 into 0. Why? Because the set S is what? Orthogonal set. That means any two distinct vector, the inner product of any two distinct vector is 0. Okay, C2 into 0 plus up to so on Ck into norm alpha k square plus up to so on Cm into this one is 0. Okay, so this implies inner product of beta with alpha k is equal to Ck norm alpha k square. Okay, so this implies Ck is equal to inner product of beta with alpha k divided by norm square of alpha k, where k running from what? Pi. काय होता k running from? For each k running from 1 to m. Okay, k is equal to 1, 2, up to so on m. Okay, any doubt?
No, sir.
Okay, so hence substituting values of C1, C2 up to so on Cm in equation 2. What we get? What is equation 2? हा वन केल्यानंतर काय कसा दिसेल हा? बीटा इज इक्वल टू C1 alpha 1 C2 alpha 2 plus up to so on Cm alpha m. Okay, हा असा दिसेल तुम्हाला. By putting the values we get beta is equal to inner product of beta alpha 1 norm square of alpha 1 into alpha 1. Okay, this is the value of C1 ना, plus आणि हा alpha 1 आहे तसंच from 2. Okay, value of C1 is from this one beta alpha 1 square norm square of alpha 1. Okay, this is beta, now inner product of beta with alpha 2 divided by norm square of alpha 2 into alpha 2 plus up to so on inner product of beta with alpha m norm square of alpha m into alpha m. What is beta? Beta is equal to summation j running from or k running from k running from 1 to m beta alpha k inner product of into upon norm of alpha k square into alpha k. Hence the proof. Okay, any doubt?
No, sir.
Okay, what we put here, काय प्रूव्ह केला आपण आता? Let S be the alpha 1 alpha 2 up to so on alpha n be the alpha m be the orthogonal set of non-zero vector. Okay, in an inner product space of V, then the vector beta belongs to V is the linear span of S. Okay, then beta is equal to summation k running from 1 to m inner product of beta alpha k divided by norm square of alpha into alpha k. Okay, wait. फर्स्ट चॅप्टर इतका अवघड नाही आहे हा. इज इट करेक्ट? फर्स्ट चॅप्टर जितका अवघड होता तितका अवघड
Yes,
नाही.
sir.
सेकंड पण इतका नाहीये. ओके, 5 थेरम आहेत फक्त सेकंड चॅप्टर मध्ये, जे मोठे मोठे थेरम आहेत 5. फक्त मेकॅनिकल पार्ट आहे, तो एकदा दोनदा प्रॅक्टिस केली की समजून जाईल. नाव नेक्स्ट थेरम इज Any orthogonal set of non-zero vector in an inner product space V is linearly independent. Okay, any orthogonal set, any orthogonal set of non-zero vectors in an inner product space V, capital V, is linearly independent. Now tell me whether the orthonormal set is independent or not.
No, sir.
ऑर्थोनॉर्मल सेट म्हणतोय तो ऑर्थोगोनल आहे विथ नॉन झिरो वेक्टर मग तो इंडिपेंडेंट होईल ना इज इट करेक्ट ओके पहा पुन्हा पाहण्याचं any orthogonal set of non-zero vector whether the orthonormal set is orthogonal
Yes, sir.
and set containing non-zero vector zero vector आहे का त्या orthonormal set मध्ये
No, sir.
no that's why the any orthonormal set is linearly independent rather any orthogonal set with non-zero vector ओके युनिटलेस नसेल तरी चालेल पण नॉन झिरो असेल आणि ऑर्थोगोनल सेट असेल तर तो लिनियरली इंडिपेंडेंट होतो ओके पुढे जाऊन या ऑर्थोनॉर्मल सेटला बेसिस मध्ये कसं फॉर्म करायचं ती त्याची एक मेथड आहे दॅट्स मेथड इज कॉल्ड एज ग्रॅम स्मिथ ऑर्थोगोनलायझेशन प्रोसेस ओके तो प्रोसेस नेक्स्ट लेक्चरला पाहूयात आपण ओके नाउ लुक एट हियर एनी ऑर्थोगोनल सेट of non-zero vector in an IPSV is linearly independent. Okay, proof. Let this yes be any orthogonal set of non-zero vector in an inner product space. Okay, we have to prove that this set yes is linearly independent. Okay, that is we have to prove that if the linear combination of vectors of S is equal to 0 then each scalar involved in that linear combination must be 0. Okay, काय सांगितलं मी if the linear combination of elements of S is equal to 0 that is C1 alpha 1 plus C2 alpha 2 plus C3 alpha 3 up to so on suppose Cm alpha m vectors are there in S is equal to 0 then each scalar involved in that linear combination is 0 that is C1 C2 C3 okay hence we get this set S is linearly independent okay
Yes, sir.
so now here we have to prove that this set S is linearly independent so it is sufficient to prove that every empty non-empty finite subset of S is linearly independent म्हणजेच काय एखादा सेट जर लिनियरली इंडिपेंडेंट कधी असतो त्याचा प्रत्येक सबसेट ईच अँड एव्हरी सबसेट ऑफ दॅट सेट इज लिनियरली इंडिपेंडेंट इज इट करेक्ट
Yes, sir.
okay suppose this is set yes we have to prove that this set yes is linearly independent that means every subset of yes every म्हणतो every okay every subset of s suppose is s1 s2 s3 s4 these are the subsets of s each and every each या शब्दाला महत्व आहे बरं का प्रत्येक सबसेट हा काय असतो लिनियरली इंडिपेंडेंट त्यातला एक जरी डिपेंडेंट झाला तर हा काय असतो सुपर सेट ऑफ डिपेंडेंट सेट इज डिपेंडेंट इज इट करेक्ट
Dependent. Yes,
and
sir.
subset of linearly independent is linearly independent okay now so here it is sufficient to prove that it is sufficient to prove that every non-empty finite subset okay every non-empty finite subset of capital S is linearly independent. Okay, now take let suppose this h dash, okay, this h dash is equal to alpha 1, alpha 2 up to so on alpha m. What is this dash? b and finite subset of finite non-empty, finite non-empty subset containing distinct vectors of S. Okay, what is S dash? S dash is equal to alpha 1, alpha 2 up to so on alpha m. N finite non-empty subset of S containing distinct vector of S. Okay, S मध्ये एखाद्या वेळेस रिपीट असू शकतात एखादा एलिमेंट. ओके, हा लिनियरली इंडिपेंडेंट दाखवायचा. याचा अर्थ काय? एखाद्या सेटमध्ये एकच वेक्टर दोनदा असेल तर ते दोन वेक्टर कसे असतात? डिपेंडेंट असतात. ओके, ऍक्च्युली सेटमध्ये एकदाच लिहितो आपण वेक्टर, दोनदा घेण्याची गरज नाहीये. Okay, so S dash here, what is S dash? Alpha 1, alpha 2 up to so on alpha m, b and finite non-empty subset containing distinct vectors of S. And each vector is distinct. Okay, here alpha 1 is not equal to alpha 2. Alpha 2 is not equal to alpha 3 up to so on alpha m. Okay, so here we have to prove that the S dash is linearly independent. To prove that S dash is linearly independent. Okay, so obviously this yes is what? Orthogonal set. Is it correct? S dash is orthogonal set. Subset of orthogonal set is orthogonal. Is it correct?
Yes, sir.
Yes मधले जर वेक्टर एकमेकांना जर हे असतील, इनर प्रोडक्ट 0 येत असेल तर S dash हा काय त्याचा सबसेट आहे. Obviously S dash is orthogonal set. So let C1, C2 up to so on Cm be any n scalar or constant such that C1 alpha 1, C2 alpha 2 plus up to so on Cm alpha m is equal to 0. And we have to show that each C1, C2 up to Cm 0. Okay, so that is in the summation form. Summation j running from 1 to m Cj into alpha j is equal to 0. Give it as an equation number 1. Okay, now again for each k running from 1 to up to so on m, consider inner product of summation j running from 1 to m with Pj alpha j, okay, with alpha k is equal to what? तर मी हा कन्सिडर केला inner product. Then by the linearity property of inner product space, this is summation j running from 1 to m and Cj. Okay, Cj is constant. Then this is alpha j and with alpha k inner product. Okay, value of this one is equal to this. Now run this g over m. Okay, so we get C1 alpha 1 alpha k plus C2 inner product of alpha 2 alpha k plus up to so on Ck inner product of alpha k with alpha k plus up to so on Cm inner product of alpha m with alpha k, which is equal to c1 into 0, c2 into 0 plus up to so on ck into norm square of alpha k, okay, plus 0 plus up to so on 0, okay, cm. Is it correct? Any doubt?
No, sir.
Okay, now what is s dash? S dash, since what is the reason? S dash is orthogonal set. Okay, so here we get the left hand side summation from j running from 1 to m cj alpha j with alpha k is equal to ck into norm square of alpha k. Okay, this is equation number 2. So from 1, what we have from 1, the value of this one is, look at here, value of this one is 0. Okay, the summation 0 केला ना consider आपण. Okay, so this is 0 with alpha k is equal to ck into norm square of alpha k. Any doubt?
No, sir.
Okay, so what is the value of this one?
0.
0 is equal to ck into norm square of alpha k. Okay, where k running from 1 to up to so on, this is m. Okay, assume this as an equation number 3rd. Since each alpha k is what? Non-zero vector. Alpha k is what? Non-zero vector. For k running from 1 to up to so on m. So this implies what? Norm of alpha k is again not equal to 0. That square is again not equal to 0 for k running from 1 to up to so on m. So what it implies?
CK.
From equation 3rd, ck must be equal to 0 for k running from 1 to up to so on m. Okay, so therefore if the linear combination 0, then each and every scalar involved in it 0. That is, if c1 alpha 1 plus c2 alpha 2 plus up to so on cm alpha m. If this linear combination is equal to 0, so that implies ck is equal to 0, where k running from 1 to up to so on m. So that implies s dash is linearly independent. Okay, S dash is the any arbitrary set. Okay, so that implies S is linearly independent. Hence the proof. Okay, so any orthogonal set with non-zero vector always linearly independent. Okay, any doubt up to here?
No, sir.
Any orthogonal set of non-zero vector in V, inner product space V, is orthogonal, sorry, is linearly independent. Okay, so in the next lecture we see that what is the Gram-Schmidt orthogonalization process. Okay, so for today it is sufficient. Any doubt up to here? जर doubt असतील तर विचारू शकता. Okay, so otherwise you can leave. Thank you for getting it.